Okay, let's get started, everyone. Just as a reminder, this classroom is a device-free zone for the next 75 minutes. Just a friendly reminder about that. A couple other housekeeping notes. Unfortunately, I will not be able to make my office hours this afternoon. However, Jack, the TA, will be there for his office hours and also on Friday. So if you need any help with deliverable 2 or 3, make sure to connect with Jack, the TA, to see if he can help you. While we're on the subject of deliverables 2 and 3, any questions? So far, so good? How many people have dove into deliverable 3? Okay, about half of you. That sounds good. Just remember, it's pretty long, pretty involved, so don't leave it until the night before. Again, friendly reminder. Okay, I think that's all the housekeeping I have for today. So let's get back to lecture. We're working our way through the second theme in the course, this idea of design. And a big aspect of HCI design is trying to make a lot of these intangibles and these sort of vague aspects of what is going to become the interaction between your user and your system, to try and make them explicit, right? A lot of them are missed during the design process and can have humorous or possibly disastrous consequences after your system is deployed. So just keep that in the back of your mind as we continue our discussion about design. The black art of HCI is recognizing before it happens what aspects of human diversity might cause an issue when the system is finally deployed. Okay, just a little bit about where we're going. As you realize, lecture 4 is a little bit long. I promise we're going to finish it today and make our way through lecture 5, which is a little bit short. We may or may not get to the first or second slide of the 6th class, which I have not put up yet, but we'll definitely tackle that in its entirety next time. Next time, we will also talk a little bit about deliverable 4, where you're going to be introducing a little bit of machine learning into your system. This is not a machine learning class, so we're going to use a very simple machine learning algorithm, which is known as k-nearest neighbors. Who has heard of k-nearest neighbors before? Just a couple of you. Okay, that's good news. We will take a fair bit of time on Tuesday to actually talk about what the k-nearest neighbors algorithm is and how it works. And you're going to then be implementing it in deliverable 4, just as a reminder to translate the x, y, z coordinates of all the bones in the hand, to take those 120 numbers and turn them into just one number, which is a number between 0 through 9. And that number, which is output by your KNN algorithm, is going to be the algorithm's guess about which of the 10 ASL numbers your user is currently signing above the device. Or that they're not signing any of the 10 numbers, right? So just as a reminder, Leap Motion out of the box comes with some machine learning that takes the values of the pixels from the 2 infrared cameras and turns that into X, Y, and Z coordinates. As you've already noticed, most of the time it does a pretty good job, but it's definitely not perfect, right? Same thing will be with your algorithm. Okay. After that, we'll continue on with our discussion about the design process and talk a little bit about information spaces and navigation. And then in a couple weeks, we'll get to talking about not technology and design, but people. So let's jump back to lecture 4. We haven't quite finished lecture 4 yet. And we ended last time by talking about this idea of verbification, right? One of the things you'll realize in user testing of HCI is that often the user will say, this is frustrating, I don't know how to use it, I'm done, or this was great, it was very usable, but there's a lot of vague terminology, right? So how do we actually figure out how the user, what aspects of your system are working well for the users and what aren't? And sort of tongue-in-cheek, we ended last time with this idea of verbification. If you create a really great killer app, your users are going to verbify it. Okay. Just to take a step back, remember we were looking at these 4 global properties of an interactive system. So in software engineering, we're usually trying to take a bunch of written requirements and turn them into code. In HCI, we're trying to take written requirements and turn it into code, and also maximize or optimize non-functional requirements. So these are requirements, things the system should have or should do, which aren't directly related to the function of the system itself, right? The system should be accessible, usable, acceptable, and engaging, which again are kind of vague umbrella terms. So what exactly do we mean by these things? Last time we were unpacking some of these terms. We looked at accessible and usable, accessible and usable. Let's move on to acceptable. And as we're moving from left to right in these 4 non-functional requirements, as usual, we're moving from things that are sort of more objective and easy to measure. And when I say easy to measure, I mean easy to measure during a user interaction. You can deploy your system to 1,000 users and see how many of them actually can use it. Now you know how accessible it is. Pretty easy to measure. Usability is a little more tricky, but we talked a little bit about how to measure that. Acceptable and engaging become a little bit more subjective and a little bit harder to measure. Systems may be usable. They may have a beautiful interface. They may be simple. The user may require no manual. They understand how to use it. But when you deploy your system out into the world, so you've done all your user testing in the lab, at the company that you work at with your users, they've come in, used it, they said it's perfectly usable, I love it, it's great. You deploy it out into the world, no one buys it, nobody uses it. Usability and acceptability are quite different. So just a take-home message from this, to remember the difference between usability and acceptability is acceptability is usually not something that can be tested in the lab setting. It has to be tested in the field, right, out there in the world. We already talked about one particular technology, which was very usable, but absolutely not acceptable. What was that technology? Google Glass, right? Works well for the people wearing it, but once people are wearing it and they go out in the world, other people didn't like it. Why didn't they like it? We'll talk about that in a moment. Okay, so again, let's try and unpack acceptable. If people don't accept it, why don't they accept it? So perhaps there are larger political reasons why people won't accept it. People may not trust the technology or it may be forced on them. I've mentioned a fantastic software system called PeopleSoft before. I hope you have not experienced that here at UVM, but if you're a teaching assistant or a postdoc or a faculty member or staff, someone who gets paid at UVM, you've worked with the system, you have no choice. If you want to receive a paycheck, you will work with PeopleSoft. Unfortunately, PeopleSoft is also not very usable, but that's besides the fact, right? So is it being forced on people? How are people having to use this system? That's obviously important. That has maybe nothing to do with the system itself. It's the larger social context around it. Then there's the issue of sort of convenience or ergonomics, which we talked about before, which is kind of the fit of the technology with the person. If you're designing a new cell phone or something that someone is, or a video game controller, something that someone is actually going to hold, then ergonomics usually means the actual three-dimensional shape of the system. Does it work? There was, before these things became standardized, there was a cell phone technology out there that had the pad, the keypad for buttons above the screen, which didn't work. It wasn't acceptable. Why not? Absolutely, right? So it was thought that people might actually hold it and type like this. I know it seems crazy, but that was the idea. And then when you gave people these crazy new things called smartphones, people tended to use their thumbs, which was just convenient. That seemed to be the way that you do it, and for most of us, that is the way that we do it. And of course, if you're holding it in that way, and you're trying to thumb keys at the top, then obviously your thumb, the meat of your thumb is occluding the screen, right? That didn't work very well. Those are sort of ideas about convenience, or this idea of ergonomics, which is sometimes literally the fit of the technology with the person. Sometimes ergonomics means sort of a fit in a metaphorical sense. Do they interact with it in the way they would want to interact with it? That was a very important issue, again, when ebooks were sort of trying to break into the market. How many people like to read ebooks? Yeah. Some but not all. It took a long time before it was actually sort of comfortable for people to read an ebook. What's the reason? The reason is that a non-ebook, a traditional book, for most people is kind of comfortable, right? There's no user manual for a book. You sit back. You can usually relatively easily find your place. You thumb from one page to the next, and off you go, right? What were some of the issues about ebooks, even if you don't remember those issues when they were being introduced? What would you imagine are some of the very important acceptability factors that you need to get exactly right for someone to choose to pick up an ebook over a book?
Battery life.
Battery life is important, and that's true for sort of all mobile technology, right? Let's really focus on the act of reading a book.
A lot of them had like a shiny screen so you couldn't read it outside.
Absolutely, a shiny screen. So what do people tend to do? They tend to read sometimes indoors and outdoors. I don't want to have a book for when I'm reading outdoors and my ebook for when I'm reading indoors, right? That's inconvenient. I don't want to switch back and forth. If I'm going to read novel X, I'm going to do it all on an ebook or on a book. And of course, reading part of that novel, sometimes I might be indoors, sometimes I might be outdoors, right? This is, again, all thinking about the C in PACT analysis, right? The context, the physical context around the act of specifically reading a book. So that was important, right? To get the screen right, to not be very reflective. What else?
The screen size was a big issue. Like, I used to read ebooks on like an old smartphone.
Yep.
And you have to scroll just all the time because there wasn't enough space.
Scrolling, right? That's a pain, right? If you open an actual book, it sounds ridiculous, but you're not actually scrolling anything with your hands. Your eyes saccade, I mean your eyes are moving from word to word on the page, but you're not doing anything with your hands to focus one part of the page, right? So that was a difference between early ebook interfaces and actual books, which was not acceptable to a lot of users. What else? Yep. Absolutely, right? So getting the reader technology to the point where it was light enough or small enough or thin enough that it actually kind of felt like a book. That was important.
If you wanted to like to go back a bunch of pages, you had to scroll.
Yep, if you wanted to go back a bunch of pages, you had to scroll back. Was that a good thing or a bad thing? Sorry? It's a bad thing, right? You have to kind of do that. Often in a book, you can sort of look edge on and go back about 20 or 30 pages in maybe one or two swipes. In the old days, you had to do page by page, right? What else? Getting very close to one of the things that was particularly difficult. We just kind of indirectly mentioned it.
Maybe like annotating or finding quotes?
Annotating, that's important, right? So the highlighter, that was important as well.
And keeping your place.
Keeping your place, right? That was important. Think about the physical act of reading a book.
Turning a page.
Turning a page, right? This was actually the sticking point for a lot of people, right? This or however you turn a page in your book. I don't know if that's still true, but a lot of the ebook interfaces went to a lot of effort to create the illusion of actually turning a page. So if you touched the screen and you pulled, the text would actually deform and warp and flip over, so it looked like you were literally turning a page. That was important for us old people who were really trying to go from books to ebooks. Maybe that doesn't matter so much anymore, but there was a lot of effort that went into the act of turning a page in an ebook. That was the difference for a lot of users between whether an ebook was acceptable or not. Very, very important. Okay, some of those aspects, again, you could count them as usability. The good point about being indoors and outdoors, not something you can really test in a lab, right? You can sort of try and get some of the interface right, deploy a bunch of ebook readers to readers, have them go out and do their daily activity and use the ebook on the subway, on the bus, outside, however they read during the day, and see whether the ebook can actually stand up to that. That's acceptability testing. Okay, cultural and social habits, we've kind of talked about that before. So again, now we're not really talking about the physical context so much, but more sort of, does it fit in with your life as a whole? Does the technology mesh with the way people like to live? Is the technology rude? Does it interrupt, assume, ignore the user and so on, right? Again, little tongue-in-cheek here, but we do want to make sure that our technology is polite. What do we mean by politeness or rudeness? Or can you think of examples of rude technology or polite technology?
I know people like to put out Duolingo.
Okay.
Has really aggressive notifications when you stop doing its lessons. So it'll be like, hey, where'd you go? Hey, come back. Like, and it just
Absolutely.
like repetitively says that.
That's very true, right? The Duolingo system is known for this aggressive notification system, and you said it reminds you, but it's not an it. It's a he or a she.
Yeah, it's an owl.
The owl, that darn owl, right? Looks lovely, and of course it's an owl, so it's wise. It's all about learning. It's calling you to a noble purpose, right? I know you're scrolling through Instagram. Whatever you're doing, it's not as cerebral as what you should be doing, which is spending time with me learning another language, right? So they thought they could get away with some of that aggressive notification because, again, it's not calling you back to social media, it's calling you up to learning and language and so on, right? But again, I don't know, you might make you feel bad, right? In a way it's being not maybe rude, but a little uppity, right? Spend time with the owl. Yes?
A little less complex, but microwaves that don't stop beeping when you open the door.
Absolutely, right? Our world in general, right? Notifications. Thank you all. This is our 5th lecture, and I have not yet heard a cell phone beep. Thank you for that. In the old days, not so much, right? We're all, as a society, learning how to deal with all our devices, which are constantly notifying us about all sorts of things, right? In the old days, it wasn't rude because there just weren't that many devices and there weren't that many apps, right? But more devices, more apps, more notifications. Collectively, our society has decided that that's kind of rude, right? Generally speaking, it's polite now for us to turn off our notifications, or it's polite for an app by default to assume non-aggressive notifications, and if we want to ramp it up, okay, right? Again, a subtle thing, but an important thing. Maybe a little bit more obvious economic aspects of acceptability. Is it affordable? Does it change the adopter's business model for the better or for worse? Maybe your software is free, but it's not acceptable because if I do take it on, it's going to start to change other aspects. I'm going to have to buy add-ons or other things, right? So cultural, economic, sort of ergonomic or convenience, political, all these other features might take something that you've spent a lot of time getting the interface right. It's beautiful, easy to use, it's usable, not acceptable. Okay, let's move on to the last one, engagement. This is the one that is most subjective and very, very hard to measure. This is the one that video game designers spend most of their time on, but more and more other kinds of interactive technology designers are also thinking about, which is basically speaking when the user interacts with their system, does that system pull the user in? Are they engaged with it? So again, this is very subjective, but you can ask the user, do they feel a sense of immersion? Did they fall into the system like you do into a good movie or a good book? Does the user feel creatively challenged or creatively inspired by a good game or by the system itself, right? So we're going to talk about adaptive software, and your final project is also going to have to be adaptive. As the user gets better and better at using the system, an adaptive system has to infer that the user is getting better and possibly change the interface or change the interaction to keep the user engaged, right? There's a very fine line when you're dealing with a game, or in your case, educational software, teaching ASL. There's a very fine line between boring your user and frustrating your user, right? How do you make sure they're in the middle? This is an idea that's been around for quite a while in psychology. It's now commonly known as flow, after a famous book written by Csikszentmihalyi. Don't worry, I won't ask you to pronounce that last name on any of the quizzes. It's a great book, actually, if you haven't read it. Talks about flow or optimal experience. So in this book, he interviews people at peak performance in a lot of different domains, sports people, intellectuals, creative types. When they're in the zone, which is another sort of word for this idea, what is their subjective experience? And most people, and you probably had this experience yourself, when you're in the zone, it sort of feels like time slows down. You know exactly what to do next. You don't feel anxious. You know what's happening, and you're just flowing through the exercise. There's no effort required, right? If you make a great video game or you make another great immersive experience where you're trying to entertain the user, possibly teach them something, where there is a bit of a challenge there, can you get your users to report a sense of flow, right? They may not know what flow is, but they might describe some of the features of what it feels like when you're in that optimal experience, right? They were really in sync with the game or with the system, right? It was a real back and forth. It was effortless. A whole bunch of time passed by. It felt like no time at all. I came away knowing all the 10 digits of all the 10 numbers of ASL. It was great. Didn't require any effort on my side. On the other side, you know your system isn't engaging if they're frustrated, right? It took a lot of effort to make even a little bit of progress. I had to push against the system to learn just even one of the 10 numbers. It was extremely, extremely difficult. Okay, so again, this is a subjective thing. So how do we actually try and optimize engagement in our system? Well, again, let's try and unpack this. One of the things that people report in engaging systems is the system sort of matches their identity or their philosophy. They see themselves somehow reflected in the system, or they see their philosophy reflected in the philosophy of the system. Apple exploited this back in the day with a series of advertisements about I'm a Mac and I'm a PC. Do people remember this? Are they still going, right? Which of these two individuals do you want to associate with? Maybe neither, or identify with, right? So the Mac over here, right, he's young, good looking, he's always in fashion, he's always relaxed, no problem, we'll figure it out, right? The other fellow, unfortunately, a PC, he's always in trouble, he's wearing a business suit, right? It implies that Windows machines are just for, office boring things, you wouldn't use it in your normal life. There's a lot of subtle messages hidden in this advertising campaign, but at root, obviously, they were exploiting the fact that you might associate with one individual over the other, right? Adaptivity, we already talked about this. Can your system adapt and keep up with you so that you stay at that middle level of feeling challenged? It's not too easy that you're bored, not too difficult that you feel frustrated. Does the system tell a good story, right? Again, this is important in video games. There's a beginning, a middle, and an end. There is some sort of goal at the end. As you're interacting with the system, you can clearly tell at any point in time whether you're moving towards the goal or away from the goal, how much further do you need to go to reach your goal, and so on. We'll talk about that more when we talk about navigation in information spaces. Often when people get frustrated with software, they say they're lost, right? They don't know where they are. How do you help people navigate through a complex interaction with a software system? What are some examples of non-video games, other systems where you felt this sense of narrative? You can feel yourself moving towards the goal, and it's clear at any point in time sort of where you are and where you're going.
Some websites have some sort of section heading at the top that tells you which links you've clicked on.
Okay, so at the top of a website, you often see section headings. There may be main pages and sub-pages. Remember our discussion about the parable of Tempest and Hora, hierarchical organization. Hopefully, right this moment, you know exactly where you are in this course. We're in Theme 2. We're in the second lecture of Theme 2. We're at the end of we're reaching the end of the second lecture. We all kind of know where we are, and you know where we're going. Lecture 5 is next, and you know next week we're going to reach some new theme, and so on and so forth. What are some other examples of technology that provide that feeling of narrative?
I was going to say filling out the FAFSA form.
I don't know what that is. Tell us a little bit more about that.
It's a federal aid form, and it follows the principle of modularity, and if you have to do one to get the other, sometimes it all fails and this doesn't.
Exactly.
There's a final at the end, and it shows your progress.
Gotcha, right? So filling out complex forms on the internet, it's a lovely experience, right? So luckily people have started to figure out how to make this a little bit easier so you don't get lost filling out a complex form. I hope filling out all of the steps in the deliverables is not too confusing. I know sometimes there's 18 D, I, so on, go here, go here. I've tried to give you some way markers to know where you are and where you're going and how far you have left to go and so on, right? So when you're performing a complex task, which has got a lot of moving pieces, you might not be able to do it all in one go. This idea of hierarchical design is very useful in helping people understand the narrative and where things are going. Okay, immersion, again, subjective. Does it draw you in, right? I'm sure you've all had the experience of reading a great book or watching a great movie and you just get lost in it. You forget everything else that's going on. Are there examples of interactive technologies where you've had that experience? Again, video games is kind of an obvious example, but what about other systems? VR, right? This is going to be the ultimate in immersion if they get this right. And again, it's interesting that VR has taken so long until just recently that they're starting to get it right, right? VR was promoted as the killer app in the 70s. It wasn't. The 80s, okay, the 80s is going to be when VR really takes off. It didn't. 90s, the zeros, we'll see, right? We're 2018. We're still maybe almost there. We're going to spend a fair bit of time at the end of the course talking about virtual reality and why it's so difficult. Obviously, there are the technical challenges, right? Real time, I need to keep track of head motion and all that. Why else is it so difficult to get immersion right with VR technology?
Because you can't really do the whole moving around thing unless you have a large enough room.
You can't do the whole moving around part unless you have a big enough room. That was true. And again, we're going to talk about that, right? You can't move and do VR at the same time. Or can you? What's the solution other than having a huge room? Anybody know?
Those omnidirectional treadmills.
Omnidirectional treadmills is one possible solution, and we'll look at that, right? So remember at the beginning of the course, we talked about humans. They take input, sensory input, they cogitate and produce output. But remember our discussion about John Dewey, who tried to invert that whole process. And Dewey said, we push against the world first. That's the primary thing. If you don't know what to do, if somebody doesn't know what to do with leap motion, they can sit there and look at it all they want. Nothing's going to happen. Most people will do something like this, or tap it, or pick it up, or shake it. They'll interact with it and watch how it pushes back, right? So when I push against the world with my legs and feet, there are particular kinds of sensory repercussions that I expect when I'm walking, right? So either I need a big room or I need an omnidirectional treadmill, which again is tricky. For those of you that run on non-omnidirectional treadmills, if you've ever been at the gym and you run on a treadmill for a while and then you step off the treadmill, you're a little bit dizzy for a few seconds. Why?
Something to do with like the physics of your body.
It has absolutely something to do with the physics of your body and also your brain. Remember, the brain is a prediction machine, so there's a mismatch there that's going on that makes you dizzy for a few seconds.
You're expecting the ground to keep moving.
You're expecting the ground to keep moving to some degree. It's not actually that so much. We're getting really close though, but it is expectation, right? The moment you step off the treadmill, your brain is expecting something and it doesn't happen. What is it?
Because your body just used to like your legs moving constantly, so when you get off it,
Not really. So if you run, right, you're moving, and even if you stop running without a treadmill, you don't have this experience. So it's not that your brain is used to your legs moving and then your legs stopping. It's not just the motor system, right? Remember, Dewey told us there's this continuous loop.
That's the vision system. So when you're on a treadmill, nothing's moving by you, but when you get off, things start moving when you move your legs.
Exactly, right? So for all the years that you've been around, before you ever step on a treadmill for the first time, your experience has always been when you move, the world moves in the opposite direction, right? Always. It's so clear. Your brain builds up that prediction. When you step on a treadmill is weird in lots of other ways. So your body is feeling that you're now on something that's very different. So your brain is now already prepared to deal with things that are going to break its prediction. So often you're not as dizzy when you start running on a treadmill. Your brain says, okay, something weird is happening, all right. So your brain says, okay, I'm in a weird situation now where I have the experience of running, the world is not moving. Okay, you're on the treadmill for 20 minutes, half an hour, however long you run for, and your brain builds up a prediction during that period that as you run, the world doesn't move and says, aha, I know the new situation. Then you step off back into the real world, and suddenly that prediction, which is built up over the last half hour, is broken, and you feel dizzy for a second or two until your brain says, actually, now I remember, this is normal, not the treadmill. Right? Okay. So again, with VR, unfortunately, even with a lot of sophisticated technology, we're interacting or perturbing all of those motor sensor feedback loops and the predictions your brain has about sensory repercussions for actions. One of the reasons that VR did not work in the 90s and the zeros is that even as the headsets were getting better and better, as someone wearing the headset moved their head, what they saw was correct in the sense that it would move in opposition to the movement, or sorry, it moves with your head. What you saw moved with your head. That was right, but there was something else that was still wrong that actually made people nauseous when they wore these headsets.
So when you're moving your head like that, you expect to see a different part of the world, but when you're seeing the same part, it makes emotions hit sometimes.
That's true, but again, that all got worked out relatively early on, right? So whatever the virtual world was that you were looking at with the VR headset, the right part of the world would come into view as you turned your head. But still, people were getting nauseous or dizzy because it wasn't moving fast enough, right? So in the 90s, they got it down to 1/10 of a second. In the 2000s, 1/100th of a second wasn't enough, right? You know that when you move your head, the visual repercussion of that movement is instantaneous, and any lag is extremely disconcerting, right? So it's only now that our computer technology is fast enough. There is still a lag, but it's small enough for most people not to be able to detect it. And that seems to be the main barrier that we've finally gotten over, that people wearing VR or their brains can deal with all the other broken expectations, like when I'm walking, it's not quite right, but generally speaking, when I do this, the world responds appropriately. Okay, so I think that finishes our lecture on interactive systems design as it relates to these non-functional requirements. Let's move on now to design principles. And as you'll remember from last time, design principles are kind of these rules of thumb, right? So we kind of know what we're doing now. We want to design interactive technologies that are accessible, usable, acceptable, and engaging. How do we do it? What are the rules of thumb that will help us to do that? Unfortunately, in the book, it gives you, again, a long sentence with a lot of vagaries in it. We'll try and unpack this. Generally speaking, these design principles are going to help people access, learn, and remember the system. We've mentioned that before. Giving them the sense of being in control, this is important. Knowing what to do and how to do it at any time, safely and securely in a way that suits them. Kind of vague, so again, let's try and unpack these into a few design principles. So we're going to try and maximize these aspects now. The first one is going to be visibility. So we need to make sure that people can see or hear or know somehow what options and functions are available to them. And our first design principle here is that we're going to try and make things recognizable rather than memorable. We mentioned memory is important, but it would be great if people don't have to remember a whole bunch of things to use your system, right? So we want to make things visible so that they can sort of see what's going on. This one's tricky, however, because we don't want to put too much visual or auditory clutter in front of our users, right? Remember, keep it simple, stupid. We don't want to distract the user by having to look at lots of pop-ups and notifications, and suddenly there's an alarm bell or a ding. You want your users to focus on what's happening, but you also want them to be able to recognize things. So how would we possibly make more things visible without adding more ink? Remember, we want to maximize the data to ink ratio. We want to use as little ink, as little flashing fonts and different colors and things moving on the screen as possible, yet make things more visible. Seems kind of almost impossible. In the next theme of this course, we're going to talk about cognitive psychology and people and also aspects of our visual system. There are aspects of our visual system that we can exploit to make more things visible without having to add more ink. Here's a very technical drawing to make this point here. You probably all played this game before. How many differences are there between these two pictures? I'll give you a minute to figure it out. See how many you can find and count them. I'm going to ask you how many you found, not what they are. How many? 10? Anybody find more than 10? 12? Anybody find more than 12? You have 14. Oh, not bad. Okay, you guys are awake this morning. Okay. Here is exactly the same picture. How many? Count how many. Anybody find more than 14? Well done. Okay. Very difficult to find all 14 like this. Why? Why is one easier than the other?
Because there's a lot of stuff in there.
There's a lot of stuff in there. So in both cases, I presented the same amount of ink to you, right? I just presented that amount of ink in a different way to make things easier on you. And I made those 14 differences visible without putting a circle around them or flashing an arrow nearby. You actually were able to focus more on where those differences were in the second case than the former. But why?
We're able to compare and contrast.
Compare and contrast, right? So remember in this course, we really need to think carefully about people. What exactly are you doing when you play the game this way?
Instead of you looking back and forth, the technology did it for you and you did it faster, so you were able to pick up on it faster than how you do it with your natural eyes.
Exactly, right? So you're saccading, your eyes are jumping back and forth with one picture to the next. You might see this and you see 3 strawberries and you know, oh, they always add or remove a strawberry, right? So you're looking at this, and if you look at this, this is actually still in your visual field, but it's off to the edge, and the edge of your visual field is not very good at detail or counting. You know that there are strawberries over here in your visual field, but you can't count the number of strawberries in the right-hand image until your eyes move, your eyes jump. And your brain is a prediction machine. It remembers, and you got to store this piece of information. You got to remember that there were 3 strawberries there, and okay, there's 3 strawberries there. They didn't remove a strawberry in this case, right? So there is a sensor motor loop going on here. You're pushing against the world and observing how the world pushes back. You're pushing in this case by moving by using the muscles in your eyes to move your eyes, and you're seeing how the world pushes back. Are there 3 or 4 strawberries when you land on the when your eyes land there on the second image? And you got to remember how many there are. If you look at the strawberries here, if you're looking at the strawberries, you don't need to count that there's 3. The motion part of your visual system just reports no motion, which equals no change, right? Pretty easy. Okay, the number of strawberries is easy. The shape of the frosting on the bottom layer of the cake, not so easy to see. It's possible, but difficult, right? Okay, so obviously this is a bit of a cartoon example here, but this principle of exploiting some aspect of the human visual system, which is that we can use motion as a metaphor for change, where there's I guess it's a visual metaphor, but it's also sort of an animation metaphor here. Movement equals change, that's important, right? We can exploit that. This system is actually used by certain security companies to detect Trojan horses. So when new computer circuits or electronics are designed in the United States, those designs are often sent to another country where they're manufactured. And in some cases where they're being manufactured, a black hat in that country or in that factory will introduce a change to the electronics that is very small and very subtle, so that when the electronics comes back and is incorporated into a weapon system, for example, for the military, unbeknownst to the designers of the chip and the people that install the electronics into a weapon system, that there is now a backdoor in that circuit. So how do you know that the manufactured circuit, when it comes back, matches exactly the design specifications of that circuit? It's tricky. Sometimes the Trojan horse is purely software. That's obviously hard to find. But sometimes there is a very, very minute change in hardware that is very, very difficult to detect. What's the easiest thing to do is to take very careful still photographs of all of the circuits coming back, match them up, and play this game. And sometimes if you see a subtle change, this particular diode is sitting here, but now it's off a couple nanometers compared to another chip, that is often a good telltale for interference. Doesn't always work, but again, sort of a simple trick applied to a very, very important and serious problem. Okay, it's taken us a little bit away from HCI, but I think you get the idea. Consistency is important across all the pages in your website or across all the parts of your app, or if you work for a company that develops multiple apps, you might have a common sort of style or consistency across apps. Sometimes, again, this is obvious, so that might be visual consistency. Everything in your system is a particular shade of blue, never a particular shade of green. That's an easy one. But sometimes you want the consistency to be cognitive, right? You want sort of the brain, which is a prediction machine, to sort of know that the way in which you interact with this system across different parts of the system are consistent. Consistency might be within the same system, between different systems, or as we've talked about with metaphors before, between the system and the real world. What are some cognitive, some aspects of cognitive consistency that you know of in apps or websites or other kinds of software?
Using like a floppy disk symbol as a save.
Okay, using a floppy disk symbol as a save, right? We talked about that before as metaphors. If you want to have a little icon for save in your system, it's often a floppy disk. How many of you have actually used floppy disks? A couple of you? Oh, wow, great. Okay, good to know. Awesome. All right, someday no one will put up their hand, but for now, Arlo?
File Explorer being a paper file.
Sir, can you say that again?
I guess Windows Explorer.
Windows Explorer?
You open on, click on files, it's like a paper file.
Exactly, right? It looks like an actual paper file or a folder. The very idea of folders and files, right? This was a metaphor invented right at the beginning of the computer age when GUIs or graphical user interfaces were introduced, and they're kind of universal now, right? Imagine you created a new system where people needed to store information and retrieve it, and you use something other than files and folders. That would be very jarring. You better have a very good reason for breaking that expectation that in your system things are being saved and loaded back from files, and those files or that information is hierarchically organized in folders. Yes?
Looking for the settings button in the top left or right corner.
Absolutely, right? So where things are to be found. Again, that comes back to navigation, right? Where are the settings on this? I always know they're top left somewhere, or top right, depending, right? That depends on the program, right? If I see that little circular gear, right, that in the top right, that's usually settings. Okay, let's carry on. So again, familiarity. Some of these are obviously related. Use language and symbols that the user is familiar with. And again, if you have to introduce a concept that's not familiar to your users, like the fact that you're going to save information by waving your secondary hand in and out of the frame of field of view of the leap motion device. Not many people are familiar with that particular form of interaction. You're going to have to provide a metaphor or give some sort of signal to the user about what they're supposed to do. You're going to find this particularly challenging in the final project. When you're doing your user testing, you can't cheat by turning to your roommate and say, listen, here's what you have to do, 1, 2, 3. Remember, your user does not speak English, right? They have to learn everything without you telling them what to do. How are they going to realize that from time to time they need to do that, right? You're going to have to provide a metaphor. If it's familiar things, again, use familiar language if you can assume that they speak that language or symbols. Okay. How about an icon representing a document should indicate how close the document is to completion? There's lots of visual metaphors for that. What are some of them? We were talking about filling out forms. You're trying to do something. How do you know how close you are to completion?
Progress bar.
The progress bar, kind of universal these days. Anything other than progress bars?
If there's like symbols representing each step, it might change the appearance of the symbols after they're completed.
Absolutely, right? So the symbol itself might change. There's some aspect that you're done. There's the, the slice of the pie, progress, and so on. Lots of different ways to do that. Okay, this fourth one, this is an idea that comes from psychology, the idea of affordances. This is an interesting one. We'll talk about this in a moment. Basically, in this case, what we're trying to do is design things that are seen on the screen, or maybe physical devices that the user has to hold or interact with, to advertise what they're for, right? Remember our discussion about verbification. We want to focus not so much on the noun, the thing, but the verb, the way in which the person should interact with it. So the appearance of the object or the icon or even the sound, we'll see auditory, we'll talk about auditory metaphors in a little while. The appearance of that object should suggest how it should be used. What's an example of an icon that suggests to a user how it should be used?
Magnifying glass.
Sorry? A magnifying glass, exactly, right? Whatever it is it's going to give you, if you use it or look through it, even if you're not literally looking through it, it's going to provide detail. Yep, it's a good example.
So play, pause, and next.
Play, pause, and next, right? We've talked about that one a fair bit.
A hand means panning.
Hand, right? Okay. Hand is tricky, right? Because the human hand does a lot of things, right? Now it tends to be panning, but if you see two, sometimes it means zoom in and zoom out.
Like if you just started a program, there's only one button on the screen.
Yep.
That's what you have to press.
That's a good point, right? So sometimes with the KISS principle, you might just see a single icon which says, interact with me, right? You can't do anything else except this. We'll talk about affordances in a moment, where often what you infer about that thing has to do with neighboring structure, or in this case, the lack of neighboring structure. If there is nothing else on the screen except a green button, you can be pretty sure what the system is trying to tell you. Don't do anything except press this button. Okay. So let's have a look at affordances. Again, let's step outside HCI to try and make this point. Again, this has come from psychology. We're back now to the human system. We need to think about the human visual system. What do these objects have in common?
They're all for sitting.
They're all for sitting, right? Sometimes when I ask this question, people say they're all chairs, right? You could argue about the last one. Not technically a chair, but again, you could argue it. Because chair, the noun, in our minds is almost synonymous or equal to the act of sitting. So what is a chair? In the old days, when people were trying to write computer vision software that would take in an image and recognize chairs or cats or whatever else you wanted to see in the image, they wrote a lot of code that said a chair has 4 legs. So look at the image, find a blob of continuous color and see if there are 4 vertical things coming down from it. If you took that hypothetical software, it would correctly recognize this one as a chair, but none of the rest, right? So then the computer vision designers went back and said, okay. If you see something that has 4 vertical prongs at the bottom of it, or 3, that's a chair. Still doesn't work, right? Back and forth, back and forth, back and forth. Part of the reason why it took so long to create software that could automatically recognize objects in an image is that the designers of that software were not familiar with the human aspect of recognizing affordances. Whether you realize you're doing it or not, when you look at something and you start to get the idea that maybe the answer I'm looking for is chair, you're not looking at each of these and mentally saying, does it have 4 legs? Does it have 3 legs? Does it have a vertical backrest, right? I picked these 5 images, as you can imagine now, to try and explode any possible hypothesis you could come up with for what geometrically constitutes a chair, because in order to recognize a chair, you're not really paying attention to the geometry, or more technically, you're not relying on just the geometry. You're reasoning about the geometry of the object you see. You're reasoning about your own geometry and your own movement capabilities, and you mentally project yourself into the image, and you think about what would happen if you sat on the more or less horizontal part of these objects. Would the act of sitting result or not? If I were to put you in an MRI brain imaging device while I asked you this question, the motor strip part of your brain, which is the part that sits right here at the top of your head, the motor strip would light up, which seems strange. Why would the motor part of your brain light up when you're just being asked to recognize chairs or not?
Because the same neurons fire when you imagine doing an action as when you're actually doing it.
Because the same neurons in the motor part of your strip will light up when you're thinking about sitting and when you're actually sitting, or when you see someone else sitting, or you see someone in a movie sitting. All of those acts in your brain more or less are the same thing. The details of whether you're sitting, or imagining yourself sitting, or seeing someone else sitting, those are sort of details that are further down the chain of reasoning. The important thing that links them all together is sitting, right? 5 very different objects with very, very different geometries, but they trigger something in the motor strip. You imagine something. When you see a big green button in your app, your motor strip lights up again, because whether you realize it or not, you're visually seeing yourself pressing the button, and you're reasoning about whether it will work, right? If the button is really small, your motor strip actually has to work harder, because your motor strip knows you gotta aim very carefully. If the button is big, your user is actually doing less mental work. If you've ever wondered why in the history of web design, the fonts have gotten larger and there's been more and more white space. In the old days, web pages used to be very packed and dense. Part of the reason is accessibility. Not everyone has perfect visual acuity, so it helps people read, but it also helps the motor strip. A lot of what you're reading or seeing in a web page, your brain is trying to imagine how you would interact with that. Can I reach out and click on that link? Could I grab that thing and drag it successfully, right? Could I sit on that object? Okay. What do these 4 objects have in common? Yep. They're all energy sources, right? Again, it's obvious, but you'll realize obviously I left the tree stump in there. So a tree stump is not just for one thing, it's for many things, right? And the affordance that the object projects or affords, using old-fashioned language, affords to your visual system. You can think of an affordance as an advertisement. The object is saying, you can interact with me in this way. There are thousands of different possible affordances that an object might project, and how that object is presented, in what context, is going to influence which particular affordance your brain recognizes, right? And that's important when you start to design your interface, right? So the green button, depending on what else is on the screen, might say, press me now, Or it might say, I'm just showing you what buttons look like, for example. It could be a completely different affordance. Okay, let's come back to HCI. Here's again another 4 or 5 images. What do all these objects have in common? What is the affordance that they are all projecting to you? There, you can click on them, right? Another way you know that you're projecting affordances is people will often use adverbs. It's clickable, right? You can click on them or it's clickable. Let's play exactly the same game. I'm going to leave one of these objects the same, the Wikipedia page here. What do all of these 1, 2, 3, 4 objects have in common? What affordance is being projected now? You can type on them, right? That's a good description. You can't literally type on edit this page. It's clickable, but you got the affordance, right? You know I've designed this page to try and project a particular affordance to you, which is if you click on it or whatever, you will within the next second or two be able to start typing in text, and you'll see that text reflected back to you. Right? So now we're thinking about how to design something to project one affordance or the other. The edit this page widget, I can change what affordance you infer depending on what else I put around it. Right? That's the connection between design and affordances. We'll come back to this idea of affordances many times in this course. Okay. So let's keep moving on. There's a number of other aspects here, design principles we want to talk about. We already mentioned navigation before. We want to present things to the users to allow them to, so that they can see where to go and how to get there, how many different paths are available. I know where I'm going. Can I see that there is more than one path to get there? Can I see that some of those paths, given my expertise or lack of expertise with the system, I can see that some of those paths are shorter than others. What are some examples of software systems that project navigation clues? So we already talked about the progress bar. That one's kind of obvious.
When you hover over buttons in some applications, it'll give you the hotkeys.
Absolutely, right? So sometimes if you hover over a button, it'll say there's a shortcut, there's a shorter path, but it'll usually, these days, hide all that information, assuming that, again, you don't want to confuse the users. If it's a power user and they're looking for the hotkeys, then by definition, since they're a power user, they'll know where to go looking for those shortcuts. They'll know where to go navigating to look for it. Okay. Control, this one is very important, right? Most of the time these days, with most modern applications, you can either control or seize control immediately, right? In the old days, given limitations of technology, sometimes the technology said, stop, I need to do something for a while before I let you take back control. It's relatively rare these days, but it still does exist. What are some systems you can think of where there is this advertisement where the system says, you do something, and now stop, I need to do something for a while, and I'll let you know when I'm ready for you to take control again?
Well, property view and like team views will allow people to actually see control of your computer, and they'll let you know, hey, you can get control, or hey, someone else is also control.
That's a great example. So Teamviewer, right? So remote desktop, where someone else remotely can literally take over and run your computer as if it's their own. A lot of safety and security issues there, pretty important. So it's extra important to let the user know, or the person who's physically sitting in front of the screen know who's in control at this time. It's a good example. Yep.
Something like cutscenes in a video game where it like directly takes control away from you, like show you something.
Absolutely, right? And they make sure that it's very pretty so that you're willing to sort of sit there for a few seconds and watch the cutscene in the video game. Good example.
Loading screens, they'll always try to display some sort of either just like GIF icon, or it's better the loading bar or something like that, so that you know that you're out of control for a reason. Like show up with something.
Absolutely, right? So again, rare these days, but if you have a really computationally intensive application like a game or something else, there might be a load screen. They'll try and put something up there to keep you occupied so you don't get too frustrated. Often it's, hey, you're clearly here and you're willing to wait a little bit, So you're invested in the system. Let me maybe show you some hotkeys, or here's a hint or a tip of how to do things better, which is again a subtle thing, a subtle psychological game that's being played here. I know you're bored or you're about to get frustrated. I know you are. So here's something that might help you do things faster, quicker, or better elsewhere in the system, right? It's paying you back for your patience. Systems that are impolite and just put up a loading screen and nothing else, and they're assuming that you're just going to sit there and wait. They may not even tell you how long you have to wait. Are you waiting a few seconds or a few hours? They're rude. They're not letting you know how long. They're not valuing your time, right? And you'll see people talk about systems like that. They will anthropomorphize, right? This system was super rude. It didn't care about me. It was wasting my time. Of course, the system wasn't actually consciously wasting your time, but the designers of the system failed to think about what would be the emotional state of somebody during the 2 seconds or the 1 minute of this process during which they're not in control. Very important to think about those particular aspects of the system. Yes?
According with that, I feel like recently in the past couple of years, I've seen progress bars not only do a progress bar, but they'll say what the current process is going on.
Absolutely, right? So I'm assuming that if you're frustrated, you're waiting, you want an explanation for why you're waiting, right? Which is, again, a very subtle trade-off, because often we don't want to be giving too much information, right? We're often trying to hide internal complexity away from the user so that they can focus just on the things they're trying to do. But there are exceptions to that rule, and it's during those times when I'm frustrated, why is this taking so long? I may be asking, why is this taking so long, in a literal way. I want an answer. What is it that you're doing that requires me to wait? Okay, so sometimes you need to provide feedback. And again, this one is tricky. Lots of it in different forms, as often as possible, ideally continuously, as long as that feedback is also not distracting, right? This one is very, very tricky to get right, and a lot of well-designed systems fall foul of their users for exactly that. There is feedback, but it's a little bit too distracting given what the person wants to do, right? It depends on context, where they are. Okay. Safely and securely, we've sort of talked about this before. We need to think about that. Are we going to adopt a proactive or reactive approach or stance to safety? Are we going to let people make mistakes and then give them the options to back up and recover from that, errors and omissions, leaving things out? Again, this is sort of related to control. Are you going to take away my ability to make mistakes? You may adopt a proactive stance to safety, in which you're going to say, are you sure you want to do X? Are you double sure you want to do X? And so on. Related to that, again, this proactive stance is building in constraints. You may limit what people can do to steer them away from potentially dangerous paths, unless you give them a little test or they signal somehow through the interaction that they know what they're doing. But that's tricky, because now you have a system that's adaptive. It's trying to infer the ability or the clearance level of the user before allowing them to do dangerous actions. Okay. Clearly, this is going to conflict with visibility and flexibility. In what ways? Obviously, if you're building constraints, they're going to be less flexible. How does this relate to visibility? I'll just back up for a moment here. Visibility at the top there, allowing people what to see is available. Yes?
Well, some like antivirus software, you can try to click on a web page link, it'll stop and it'll like have this big red warning sign that says, hey, you know, this website isn't safe. And then you have to go to like advanced options and such to get through it.
Absolutely. So it's presenting a lot of information there in order to be safe. Other examples?
How a lot of emails will like automatically block images from certain like emails that they think are suspicious.
Absolutely, right? And some of them won't tell you that, or at least it'll be hidden away a little bit, right? For your own good. Sometimes that's okay, but again, you got to be very careful. You got to think about who you're dealing with, what are they doing, and on what context. If you want to make something safe or apply constraints, often you want to hide potentially dangerous options. right? But again, are you sure that the user doesn't want to know, or can you make it relatively easy for them to bring that stuff back and make it visible if they request it? Okay, let's finish off the last ones here. Again, as always, we're thinking about these sort of design principles or rules of thumb, and as we go, we're getting into more and more subjective territory. Often, we want to try and make our system as flexible as possible so that people can carry out whatever it is they want to do in the way that suits them, right? We've talked about two obvious paths that usually exist in most software systems, which is the menuing or the icon or the graphical path, and then there is the hidden, the cryptic, the efficient hotkeys or remembered commands path, right? The power user path and the novice path. What are some other applications you can think of where there are many, many different paths to accomplish the same thing?
In an operating system, you can either get files with the command line or through the file navigator.
Absolutely, right? So on most operating systems, there are usually two paths, right? I can click through to find it, or I can type something in to find it. Those two paths tend to be ubiquitous. Can you think of examples where there's more than those two paths?
A lot of like really basic functions like copy and paste, you can either do it with a mouse or you can do it through the keyboard.
Yep. Okay, so again, we're back now to through the mouse or the keyboard, right? So sort of clicking on things or typing in commands.
Saving a file.
Saving a file. There's multiple ways to save a file. Is it right?
You can like do the drop-down menu and do the save and then select what you want to save it as, or you can just like use hotkey where you can press the save button.
Okay, so you can press the save button, navigate through the menus, hit Control S, three paths.
In a non-technological
Yep.
example,
Sure.
like cooking.
Okay.
So you could like there's tons of ways to make a meal, but like you're still gonna eat.
That's a great example, right? So if you're thinking about a sequence of tasks, a sequence of steps like a recipe, right? And there are a lot of those in software systems. Does the order matter? In the deliverables for this class, absolutely order matters, right? You can't jump to step 23. You know you're going to get into trouble. That one's kind of obvious. But there are other situations where order maybe doesn't matter so much, and there may be sort of signals saying, here's the different ways you can do it. Option A, B, C, D, and E. Let's link this idea of flexibility to navigation. Think about the internet. You're trying to go from page to page on the internet. There's lots of different ways to do it. That's the beauty of the internet. It's a network. There are a lot of paths from point A to point B. What are the different ways that you navigate from point A to point B on the web?
You could click a hot link.
You can click a hot link, right? I click and go from A to B. What else?
That could be in your history, so you could just go to the history bar.
Go to history, right? Maybe there are places that I visit often. So again, we're going to talk more about navigation, right? So often systems these days are annotating automatically places that you visit often, and they're making it easy for you to call up those annotations like in your history and go right there. There's two paths.
I know that smartphones now, based on your location, will recommend apps, at least.
Okay, that's right. So let's imagine though we're trying to get to a specific page, right? So again, but again, geolocation is a good one, right? It might say the location, the thing you're trying to pull up is relevant to this position or not. So I know you're trying to get to B, but maybe B is not relevant at your current location.
You can TP into the server from your command line.
You can type in directly to the server from the command line, right? So there's sort of direct paths.
You could search it.
Sorry?
You could Google it.
You could Google it, right? We could search for it and click on it. So search is another option. What else?
You could, in theory, just put the IP address of it if you know.
If you know the IP address, right, the hardcore way of getting there, you could type it in or type in the URL or the IP itself. So there are lots of different ways to travel through the internet, which again might seem obvious, but that's part of the reason why the net is so popular. There are a bunch of Wikipedia games you can play. So for example, I can give you two random Wikipedia pages, and I can tell you can only click on links in page A. What are the fewest links you need to click on to get to page B, right? There's a whole bunch of games like that. There's another game where on any Wikipedia page, you have to click on the first link in the text. In the new page that comes up, you click on the first link in the text on that page. And amazingly, which nobody designed, you will eventually end, no matter where you start, they all converge on one page. What is it? Not menu. Now you got to click the first link in the text. So we're trying to restrict our movement through Wikipedia to semantic space, right? All the topics of human knowledge. If you know, don't say it. I know you don't have your device now, so you can't play it. After class, go play that Wikipedia page, and you'll see where you end up. Kind of interesting. Okay, style. This one is kind of obvious in HCI. We want things to be attractive, clean, simple, harmonious. Again, these are kind of vague. What exactly do we mean by that? Later, we're going to talk about ways of trying to actually measure these aspects. We've spent a bit of time now already talking about convivial software, right? Software itself, unless you're an animist, the software is not actually polite or actually rude, but people will attribute those human qualities to the software. So often, if people have a good experience with your software and you ask them to describe it, they'll say, oh, the system was interested in me. The Duolingo owl really cares about my education. There was a reason why he or she was so adamant in trying to get me to come back, right? It's deferential to me. So if a notification comes up, it should provide an easy way for you to get rid of the notification. I know I'm bothering you. I know you're in charge. If you don't need me, just say so, right? It's forthcoming. So if you say, listen, I want to know why I'm waiting so long on this load page, it immediately has an answer for you. Software has common sense. What does that mean? A lot of software does not have common sense. What aspects of software might cause a user to come away saying, yeah, that system had sort of common sense?
I would say a system would have common sense if it conforms to your own common sense.
Okay, right, so we talked about that before, identity. I have common sense. I don't blindly follow the rules, even if the rules don't apply in this situation. You know, I can sort of adapt, and this system does as well. What are examples of systems that actually do that? They sort of exhibit common sense.
For like Word, before you close it, you forgot to save common sense is to go back and save it so the system reminds you in case you want to save this document before closing the window.
That's a great example, right? So imagine you write an app where if the person closes it without saving, the system just throws away what you were working on and doesn't tell you, right? You didn't say save. I did exactly what you told me to do, right? It's perfectly logical, not a lot of common sense, right? It seems so obvious you probably wouldn't program a system to do that, but there are more subtle examples of that, right? Where the user has expectations, right? I'm human, I know I'm fallible, I'm going to forget things, but there's some obvious things that I'm usually going to forget that I expect you, the system, to remember and do, right? You have common sense, and the common sense I might want you to have is that humans are fallible. Okay. It might anticipate my needs, but this one is pretty tricky. It can often conflict with control. It's responsive to me. It gives instant gratification, right? Again, you don't want a system that says, wait a second, I'll give you an answer to your question in a minute, right? It's taciturn about its personal problems. If you remember the Windows blue screen of death, whenever the computer died, it would come up with an error message. Warning, I failed because of error 13672.3, which as you obviously know is about some BIOS detail I've never heard about before, right? Most users of Windows machines at that time did not care which particular error caused their computer to crash. What they cared about was, fine, you crashed, you're not perfect, shut down and restart as quickly as possible. Don't spend time telling me about what your problems are. I don't care. But on the other hand, sometimes you may want to know, why are you taking so long? As long as you're asked, then it might be forthcoming. It may be forthcoming and give you information about what's going on. It's well-informed. It sort of knows what's going on and so forth. It's self-confident. It doesn't ask you at every moment, did you mean this? Do you want me to do A or B? Do you want me to use this widget or that widget? Just get on with it, right? Okay. It stays focused on the task. It's fudgeable. Let's end with that one. What does fudgeable mean? Or what are some obvious examples of fudgeable software?
Maybe autocorrect.
Autocorrect.
Screw up your word, whatever it was.
Absolutely, right? Autocorrect, again, took a long time to get right, and it's not perfect, and the web is full of hilarious examples of where it wasn't right, but fudgeable. Humans don't type words perfectly all the time. Clean things up. Okay, we'll leave things there. You have a quiz due tonight. No office hours for me today, but Jack does have his office hours, and I'll see you on Tuesday.